All right, today we're going to talk about adding and subtracting radicals. So those are things that are, kind of broken down to their square roots and whatnot. But the thing about adding and subtracting radicals is it's kind of like with equations, they need to be like terms. They basically need to have the same root next to each of these in order to be combined. So, for example, let's look at this first problem here. I have a cube root of 108 and a cube root of 4. So I want to break this one down to a cube root of 4 in order to combine it. So, since I know what kind of root needs to be left over, it should be pretty easy to figure out. So basically what I'm going to do is I'm going to take 108 divided by 4. Gives me 27. Now, can I break 27 down to a cube root? Yes. It would break down to 3 times 3 times 3, so it would break down to 3, right? So I'm going to take 3 out, and it would leave a cube root of 4, and it would be 3 times negative 3, which is negative 9, cube root of 4, plus 3 cube root of 4. Now, when we combine them, the cube roots are just going to be the same, just like if we were adding something with an x and an x. What you actually do is you combine the coefficients in front. So the negative 9 and the 3 would combine to become negative 6, cube root of 4. And that would be your final answer. Okay? Not too tough, right? Let's do another example. Let's look down here at number 3. So again, I want to get this 162 down to a cube root of 6. Since I know what needs to be left over, it should be pretty easy to find. 162 divided by 6 is also 27. So I can take out a 3 from here and move it in front, multiply it with that 2. So I'd have 2 cube root of 6, and then 2 times 3 is minus 6 cube root of 6. Okay, now combine them. Again, you're just combining the coefficients. So that 2 and the negative 6 combine to become negative 4, cube root of 6. And that's your final answer. Okay, not too tough. Let's come down here and let's do one of these beasties here. So let's look at number 11. So number 11, I want to get these to where I can actually combine them. Now, the issue with number 11 here is this 6. It doesn't really have anything it can take out, and none of these others have multiples of 6. So this is going to be one that just kind of like stays there. There's nothing to combine it with. Okay, but these others I can simplify. Because these, I should be able to get down to a square root of 5, right? I can take out a 4, because that's easily a square root of 2, right? So I can take out a 2 from each of these, leaving a square root of 5 in each of those. So let's go through, rewrite this monster problem here. So if I take out a 4, it becomes 2 times 3, which is negative 6. So minus 6, and what's left is 5. Okay, and then plus 3 square root of 5. And then same idea, this is the same as 4 times 5, right? I can take out a square root of 4, which is 2, so 2 times 2 is 4, minus 4 square root of 5. Okay, now I combine my like terms. So I've got this, the square root of 6 doesn't have any like terms, so it's just going to stay there. Negative 2 square root of 6. But these three all have a square root of 5, so they're all like terms. I can combine them. Negative 6 plus 3 plus negative 4. That would end up being negative 3, negative 7. So minus 7 square root of 5. And that as simple as I can get it, so that's my answer. 2 square root of 6 minus 7 square root of 5. And that's pretty much all you're doing. It's just like combining like terms, finding the factors, taking out the ones that can be square rooted, cube rooted, whatever. And that's it.